Section 2.9, Translating English to Symbolic Form. And this is what we're going to do, translate English to symbolic form and translate symbolic form into English. So a note to start this, every universally quantified statement can be expressed as a conditional statement. What does it mean? It means if we have a property P, then instead of writing for all n in S P of n, we can say if n is in S, then P of n. They mean the same thing. So every universally quantified statement here can be expressed as a conditional statement here. So let's translate these English sentences into symbolic form. First, Goldbach's conjecture, a very famous math conjecture. Every even integer greater than 2 is the sum of two primes. So let's define P as the set of prime. It'll make it easier. Then we can write it like that. For every n that is a natural number, there exists two prime numbers such that P1 plus P2 equals 2n. So for every natural number, we now double it, so we have an even integer, and this even integer is the sum of two primes. Example B, at least one of the integers x and y is even. So what we mean here is that x is even or y is even. And notice how the word in English is and, but really what it means is or. X is even or y is even. So we can write it like that. If we've defined e of x to mean x is even, then we can also write it like that, e of x or e of y. And the important detail in this example is that and means or. So never forget the logic from the English language. C, the integer x is even, but the integer y is odd. So same case here, we have an English word that we should translate differently in logic. The word but here means and. The integer x is even and the integer y is odd. So we can write it like that or like this if we've defined e of x. So here but means and. So write the following statement in English. It's a long statement. Let's just read it first. There exists n in n such that there exist a and b in n, a different from b, such that n equals a squared equals b cubed. So if I re-express this a little bit better, there exists a natural number n such that there exist two different natural numbers a and b for which n is the square of a and the cube of b. If we don't really understand what this means, there's an example. We can make up as many examples as we want. If n equals 64, so there exists n. For example, here I exhibit one example, n equals 64. There exists a and b, a is 8 and b is 4, such that 64 is 8 squared and 64 is 4 cubed. That's it for section 2.9. Thank you for listening.